Students, this is program number 8, program to implement Dijikstras algorithm. Dijikstras algorithm is used to find the single source shortest path. The problem solution goes like this. You need to create classes for graph and vertex. Create a function Dijikstra that takes a graph object and a source vertex as arguments. The function begins by creating a set unvisited and adding all the vertices in the graph to it. A dictionary distance is created with keys as the vertices in the graph and their value all set to infinity. Distance of source is set to 0. The algorithm proceeds by finding the vertex that has the minimum distance in the set unvisited. It then removes this vertex from the set unvisited. Then all the neighbors of this vertex that have not been visited yet have their distances updated. The above steps repeats until the set unvisited becomes empty. The dictionary distance is returned. The algorithm works for both undirected as well as directed graphs. Before we get into the Python program, let us just analyze this with a simple graph. So here I have taken a undirected graphs. There are 5 vertices in this. So we are going to start with the first node, that is A, source node. So source node A to all the other nodes, what is the distance calculated? And it must be a shortest path. So that is our problem statement. So A to A, the distance is 0. So I'm updating in the table here. So the vertex is A, shortest distance from A is 0. Next, what are the adjacent vertices to A? The adjacent vertices to A are D and B. When you look at the distance, one is going to be minimal compared to 6. So the next vertex, what I will be visiting is D. So you can see here in the visited, I am maintaining one list called visited. The first vertex was my source node. The next vertex, what I'm going to visit is D. Now, for D, the parent node is A. So I will update here in the table. So I have written down all the vertex and I am updating here. So once I visit D, and from my source node A to D, the distance is 1. So shortest distance from A is 1 and the previous vertex for D is A. I have updated. Next, I am looking at the adjacent vertex of D. So for D, the adjacent vertices are B, E and A. Among this, A is already visited. Now if you look at B and E, the shortest distance being D to E is 1 compared to D to B being 2. I will select this vertex E. So the vertex E is selected, shortest distance from A to E is 2 and for E the previous vertex is D. So I will also update in my visited list. The next vertex what is visited is E. After I visit E, I look for the adjacent vertices of E. So for E, the adjacent vertex are D, B and C. So D is already visited. Look at B and C. So if you compare E to B is the distance is 2 and moreover whenever you look at the distance, okay, so you have to look at the distance from the source node A. Okay, so now if you look at this, now if I want to travel from A to E. Now, first of all, let us say which is minimal here. The minimal here is 2. Among 2 and 5, minimal here is 2. So I will visit the next vertex as B. But to visit B, I have to calculate the shortest distance from A. So I can travel only from already visited vertex. So the vertex selected is B and the shortest distance from A is 3. How 3? I will be traveling from A to D and D to B. So the total distance will be 1 plus 2, that is 3. Okay. So now all these vertexes are visited, right? And now I have to look for the adjacent vertex of B. Now the adjacent vertex of B is C and E. Among this E is going to be already visited. Now C has to be visited now. When I want to visit C, I can travel, I have to look for the shortest distance. Either I can go like this, A to D, D to E, E to C, or A to D, D to B, B to C. So I can travel only from already visited vertices. So A to D, D to B, B to C. That way I can travel, or I can travel like this, A to D, D to E, and E to C. So this gives me 8 and this gives me 7. So I pick up the smallest one. So from A to C, I'm going to have my shortest path like A to D, D to E, and E to C. So that is gives me the shortest distance is 7. To summarize, A to A is 0. So all the nodes are visited. Now unvisited becomes empty. Now to summarize, A to A is 0, right? And A to B, how do I travel? A to D, that is 1. D to B, that is 2. So 1 plus 2 gives me 3. Now A to C, that is A to D, D to E, E to C, gives me 7. And for A to D, directly we have a path. A to D, the distance is 1. And for A to E, I travel through D. It is A to D, D to E. That gives me the shortest distance from A to E as 2. Okay. So with this understanding, so this is what I want, right? So with this understanding, let us go back to our the Python program, how we can achieve this. So now what I am doing, we will go to the main driver method, then understand this. So the driver program, I'm just calling this G is equal to graph of 9. So there are 9 vertices in this graph. So once I call this, the constructor will be invoked. So I have created a class graph, and using a unit function, I've initialized my graph. So this is unit, this is going to be a constructor. So using constructor, I have created a graph self with the vertices. So vertices is 9. So I have passed 9. So self dot v is equal to vertices. So 9 vertices are there for this graph. So once this is initialized, next I have to create an adjacency list for the graph. So how do I create the adjacency list? G dot graph is equal to, so there are 9 vertices. So 0 to 0, 0 to 1, 0 to 2, like that. If I start my nodes from 0, then it is like 0 to 0, 0 to 1, 0 to 2, like that it comes till 8, right? Fine. So now all these values I have given, wherever there is a path, the distance, I have given the values. So G dot graph is equal to this complete adjacency list has to be created. So here, this statement, self dot graph is equal to 0 for column in range of vertices, for row in range of vertices. So this statement creates a adjacency list for the graph. Okay. So once adjacency matrix is created, I am calling the function called Dijikstra, G dot Dijikstra, and I am passing the source node, source vertex, that is 0. So once this function is called, the Dijikstra, what is the purpose of the Dijikstra function? So here Dijikstra function is defined. So this is a function that implements the Dijikstra single source shortest path for a graph, and it is represented using adjacency matrix representation. Okay, so here what we do is I'll be setting the distance as sys dot max size star self dot v. So the distance has to be set, and here sys is nothing but I have imported sys. This is a library for int underscore max. So once I set that, the distance of source will be set to 0. So from like we saw in the previous example, A to A it is going to be 0. Now I'll have one more special set list where this kind of visited list I'm maintaining, and initially all the vertices will be made to false. It is mean it is not visited. So false star self dot v. Next, for count, this is a kind of count and range of self dot v. We have to pick the minimum distance vertex from the set of vertices not yet processed. Now we need to calculate the min distance. So once the source node is fixed, next I have to look into the adjacent vertices where the path, the distance is going to be minimum. So for that, self dot min distance of the distance I am passing and the visited array I am passing. So that gives me the function where I could encounter a vertex with a minimum distance value. So once min distance is called, the control goes to the min distance definition. So this is a utility function to find the vertex with the minimum distance value from the set of vertices not yet included in the shortest path tree, right? So as and when I select a particular vertex, I will be including in the shortest path tree. Okay, so here I will initialize my minimum distance for the next node. That is, min is equal to sys dot max size. Next, I want to do a search for not visited, not nearest vertex, not in the shortest path tree. So for v in range of self dot v, if distance of v is less than min and the visited of, that is visited array, special set array of v is equal to false. So I have two conditions here. So obviously this condition will be true. SPT set of v is equal to false because I have made all the vertices as unvisited. Now I have to check for the distance. So distance of v less than min, right? So min, I have made the maximum size. See, if you can see here, in the Dijikstras function, I have set my distance as maximum size. So I have among all the path, whichever is maximum, I have set as minimum. So I have to start checking if distance of v is less than min. So this is the maximum size, and we have to look through the adjacency list, and whichever is very minimal, that will be selected. So distance of min is equal to distance of v, and minimum index will be equal to v. So with this statement, I will get the minimum return min index. So I will get the index of the vertex, of the adjacent vertex, which is very much minimal. Okay, so that is going to be returned by this function. So once this function is there, returned, the index is returned and it is placed in U. Next, put the minimum distance vertex in the shortest path tree. So this SPT set is the shortest path tree. So I'll make this U as true. So I have to make it visited. Next, what I have to do, I have to update the distance value of the adjacent vertices of the picked vertex only if the current distance is greater than the new distance and the vertex is not in the shortest path tree. So next, what I have to do, I have to update my distance because my objective is to calculate the distance from the source node. So each and every time I encounter the adjacent vertex, and when I calculate the path, I have to calculate the distance from the source node. So I have to update my distance. So for v in range of self dot v, if I'm checking for all these conditions, that is self dot graph of UV is greater than 0 and SPT set of V is equal to false and distance of V is greater than distance of U plus self dot graph of UV. If all these conditions are met, please, this statement will update my distance. So distance of V is equal to distance of U plus self dot graph of UV. Then I print the solution. Okay, so after updating the distance, I print the solution of distance. So print solution is defined here. So we'll just go and check what is print solution doing. So definition of print solution is here. So it will take two parameters. One is self graph and distance. So print vertex distance from the source. This is just a print statement for node and range of self dot v. Print node is equal to t comma distance of node. So I'm trying to print the vertex distance from the source node. For example, I want to print from 0 to 0. 0 to 0 will be 0. Then I wanted to print from 0 to 1. So that is going to be printed. So I have taken the 9 vertex graph and I have initialized my adjacency list also. So accordingly, I want my source vertex is going to be 0. So 0 to 0, what is the distance? 0 to 1, what is the distance? So it goes on like that, right? So what would be the shortest path from the source node 0 to all other nodes? So that is going to be done in the program. So the printing part is also done. So this is what we are going to check how it is going to work. So this is a Python program. So what I have explained here only I have written in this. So let me run this program and show you. So you can see the output here, right? So here the 0 to 0, 0 to 0 will be 0. Next, you can see here 0 to 1 will be 4, right? So 0 to, so the t here is the distance, okay? So 0 to 0 is, the distance is 0. 0 to 1, the distance is 4. 0 to 2, the distance is 12. The shortest path is 12. 0 to 3, the distance is 19. 0 to 4, the distance is 21. 0 to 5, the distance is 11. 0 to 6, the distance is 9. 0 to 7, the distance is 8. 0 to 8, the distance is 14. So here in the console, you can see all these values. I think all of you are able to see these values. It is vertex distance from the source. So my source node I have passed here. Here you can see g dot Dijikstras of 0. So source node is passed. So from 0 to all the other nodes. So since it's a 9 vertex graph, up to 0 to 0, 0 to 1, 0 to 2, up to 0 to 8. What is the shortest distance I am getting? So that is getting printed. It is getting printed here. So that's it, students, about this